Okay, good. I think. Oh no. I mean, these are. Shinhao not here. Eh? Okay. Okay, can see the document, guys? Can you hear me?
Yes.
Can see the document, eh?
Yes.
Okay, good. So let's recap what we learned about capacitance. And today we just do questions about capacitance. Eh? Okay. So what do you know about capacitance? Okay. So first formula, what do you learn? What is capacitance? What is capacitance? So it's making a oh, capacitance is what? The amount of charge stored per unit volt. The amount of charge stored in each plate. You must say each plate. The amount of charge stored in each plate per unit volt applied across the plate. Across the plate. Okay. Capacitance. Okay. The amount of charge stored each plate. Don't just say the amount of charge stored. You must say the amount of charge stored in each plate per unit voltage across the plate. Okay. Second formula you learn is about what? The series parallel. Capacitor when connect series parallel, you know all the formulas. The V is the same as your resistance. Now your current is changed to charge. Okay, total charge. Series, the total charge is same. Okay. And third is your series, the total capacitance, 1 over C total, 1 over C1 plus 1 over C2. Parallel is C total is C1 plus C2 and so on. Yeah. And here Q total in parallel is the Q1 plus Q2 plus Q3. That's what happened for current in your resistor. Then finally, third, you learn about energy. What is the energy formula for capacitance? Half QV, half CV squared, half Q squared over C. Remember, these are the three formulas. Okay. So based on that, let's go to the Pastyear. So these are Pastyear questions. I discussed from the bottom. Okay. Because the previous videos are from the top, so I unable to finish all the questions. Maybe I start from the bottom. Okay, go for the question from. Okay, yeah. So I go from question 5. Question 5, which year? June 8. June 8, question 5. Okay. Can you see the questions, guys?
Yes.
Together. A capacitor C is charged using a supply of 8 volt. It is then discharged through a resistor R. The circuit is shown in figure 5.1. Okay. So 8 volt to charge the capacitor, and later the switch is closed to the right to discharge across the R. Okay, the variation with time, the potential difference across the resistor R during the discharge is this. This is the discharge graph. Okay. Okay, now the question is, during the first 1 second, the discharge of the capacitor 0.13 joule of energy is transferred to the resistor. Show that the capacitance of the capacitor is 4,500 microfarad. Okay, how do you do this? At 1 second, the energy release is 0.13 joule of energy has been transferred. What is the capacitance of the capacitor? At 1 seconds, the energy release is 0.13 joule. Okay, anybody? What energy formula to be used? Half QV, half CV squared, half Q squared over C. Which do you think suitable? We need to prove that C is 4,500 microfarad.
Depends if vote or charge is given.
So what do you think is, do you think should be
Or
available
vote.
here?
Okay. One of
Volt is,
one over wait. One over
yeah,
two
volt.
CV squared.
So half CV squared final minus the half
Vote.
CV squared initial, right?
Yes.
Okay. Actually, should be initial minus, you can put like this, lah. Half C, yeah, should be initial, initial minus the final, because final energy is lower. So half C, so it's going to be V initial squared minus V final squared. So half energy we know already, 0.13, and C we are looking for. V final, V initial, how do you get? So you get it from the graph. So 8 is your V initial. Final is what? So because they say because it's only 1 second. So you go to 1 second, go to 1 second. So check the voltage somewhere here, somewhere this value. You can read half of the smaller scale. So I think this is, how much is this? I think 5 boxes is 3. This is center, so I think it's about 2.5. 2.5. So what do you do here? 8 squared minus 2.5 squared. Okay. Some students make a mistake. Some students make a mistake like this. Half C, they put 8 minus 2.5 squared. Is it correct? Is this method correct? You put the square outside, mathematically correct or wrong? So this is wrong, right? Okay. Square inside, square should be inside. Okay. Then rearrange, you can find the C. Please calculate for me, someone. What do you get for your C? You get 4,500 microfarad. So 8 squared minus 2.5 squared, bring the other side, 0.13 divided by that value times 2. So you should get around 4,500 microfarad. Okay, so this is the concept. First, those who identify should be half CV squared, good. Okay, then this is how the working should be. Any questions? No questions, Okay, so let's move on. Okay, B. Guys, come on. Think, read, think which formula to use, how to go about to get the 2 mark. Okay, so please draw the arrangement. The above circuit, they use 8 volt. They use 8 volt of power supply to connect a capacitor which has a capacitance of 4,500 microfarad. They want to get capacitance of 4,500 microfarad. But unfortunately, the person who have fixed this circuit, if he only have a 4,500 microfarad few capacitance, but maximum voltage, safe voltage is found to be only 6 volt. So you can't fix one capacitor with 8 volt power supply. The power supply is 8 volt. So you can't fix one 4,500 microfarad. Yeah, you're going to blow. So how do you do an arrangement? How do you do an arrangement here with few 4,500 microfarad in such a way that the total is still 4,500, but all are safe, never breaks. Means all occupies a voltage less than 6 or 6. Is anyone? On top, you do how many? Yeah, top and bottom, right? So top can be 2, right? Can we have 2? I think this works, right? This works. Is it total 4,500? 4,500, 4,500, 4,500. What do you get? Up you get actually 2250. All right. The top is actually 2250, half of the 5,000, because 1 over 4,500, 1 over 4,500 give you effective on top. Bottom also another 2250. So total is 22500. 2500. Okay. So this is the connection. Any part you don't understand? Okay. So those who know this is the arrangement, or you can do like this, or you can do like this. You can do 2, then connect another 2. Also can. This also can. Okay, you still get 4,500. Okay, so when you connect like this, each capacitor take how many volt? Come on. Each capacitor will take how many volt? Anybody?
2.
2 volt, because we are applying here for 8 volt, you know. So 8 volt, yeah, like 8 volt. Yeah, you give 8 volt. You apply 8 volt. So up to capacitor, down to capacitor. Use the Kirchhoff second law. So each capacitor take 4 volt each, right? 4 volt, because supplied here is 8 volt. So all going to use 4 volt. So is it safe? Capacitor is safe because the safe voltage is 6 volt. So it won't explode. It won't explode. At the same time, so total capacitance found to be 4,500. So this is the arrangement. Okay. Any questions? Remember, the safe working voltage 6 volt means you must arrange such a way that the voltage across each capacitor is either 6 or lower than that is fine. Not need to be exactly 6 volt. Less is fine as long as they never explode. Okay. Let's move on. Okay, that's the first one question. 2 mark, 2 mark, so about 5 marks. Okay, go up. Okay, this electric field. Okay, we go to this question. This is your November 7. Okay, question 5. Okay, again, guys, read the question, think, suggest me an answer. State one function of capacitor in simple circuits. Anybody? Shinho, yeah. Shinho?
Yes.
What do you think? One function of the capacitor in a simple circuit. Where we can use capacitor.
Whole voltage.
Yeah, again?
Whole voltage.
Whole voltage, about magnet. About your form 5, you learn smoothing. Smoothing of what? Smoothing of?
Smoothing of magnet.
DC circuit, DC voltage. Smoothing of DC voltage recovered from AC power supply, AC voltage, recovered from AC voltage. Smoothing of DC voltage recovered from AC voltage. Okay, we can use capacitor. Another function of capacitor is what? To block DC current to flow to the what do you call it? DC current to flow to the microphone. At the same time, allow AC to flow in the circuit. That's another one use. But easy one is the smoothing. Smoothing of DC voltage recovered from AC voltage. Okay, acting as a smoother. You know the ripple, right? The ripple, I think from 5 we learn, right? The ripple of DC, we connect them by connecting by using a capacitor. Okay. Okay, B. Okay, look at B. So 15 volt connected to a 12 kilo ohm of resistor, a 15 volt of capacitor, a charge capacitor, 15 volt connected in series is 12 kilo ohm. Okay, the switch is closed and the variation of T current circuit is shown in the figure. So the current of the capacitor was dropped, or across the resistor drops like this, okay, exponentially. Initial current we can see. Okay. So this is the I versus T graph. I versus T graph. Okay, now question. State the relation between current in the circuit and the charge that passes point in the circuit. What's the answer? What is the relation between current and charge? Anyone? This is your AS knowledge, right? Current is?
Directly proportional.
Yeah, good, you can see it. State relation between the current and the circuit and the charge that passes through the point. Say the relation. Current is directly proportional to the charge, or you can say current is rate of flow of charge. Current is rate of flow of charge. Okay, next, the area below the graph represents the charge. Okay, they help you. Cambridge kind, they say the area under the graph is charge. Determine the initial charge thought in the capacitor. 4 marks, quite a lot. The area below the graph is represents the charge. Determine the initial charge thought in the capacitor. Okay, how you can find the initial charge? This is current versus time. The area under the graph, they say charge. So what do you have to do? So what is the charge thought? So I think this is straightforward. A lot of mark, but straightforward, right? They already said the area below the graph is charge. So determine the charge thought. So I think we just find the area under the graph. Okay. So I think you draw a straight line. I think you can draw a straight line here. Okay. Maybe from the beginning to the end, you can draw a straight line. Okay. This is the first triangle area. The next, maybe from these boxes, maybe you can calculate. Okay. You can calculate these boxes manually. Then you add them. Each one small box, you know, 0. This is how much? 0.5 divided by 20. I think it's 20. Yeah, it's 20. So this is 20. So the one box value is how much? 0.05 divided by 20. And the time for one small box is how much? 5 divided by 20, if I'm not mistaken. Yeah, 5 divided by 20. So each box is 5 divided by 20. So you can find the area of the one box, small box. Okay. So here the number of small boxes roughly you need to calculate. Okay. Then you add them, you get the charge. But the area is the charge, but the charge you get will be what unit? Will be what unit? So the unit is here milliampere. So here time is second. You have to be careful every time when you have a graph, check the unit. They try to trick you with the giving what do you call, not a SI unit. So here in this case, the area you calculated will be what unit? Will be millicoulomb. Millicoulomb. So milliampere times second one. It's millicoulomb. So the area you get here, but they want microcoulomb. So what do you have to do? So this millicoulomb, what do you do? You multiply by 10 power of 3, right? You get in terms of microcoulomb. So that conversion you must do. Millicoulomb change to microcoulomb. Okay, so this is the idea you should have when you read this question. Must find the area under the graph. Area under the graph, you can draw a straight line, try to make it at a triangle. So big portion we can calculate by using a uniform, what you call shape. We use triangle area, easy. Then we have the remaining one, we can't create one shape, so we just count manually. Okay, and these two area we add, the total area is in form of millicoulomb. Millicoulomb change to microcoulomb times 10 to the power of 3, you get the answer. Okay, we're just talking about the idea. Yeah. Any questions? Okay, so that's the idea for this question. 4 marks, quite a lot. Okay, now assume we know the charge it's stored. Okay, we know the charge is stored. How do you do part 3? What formula do you use? Anybody?
Q over V.
Q over V. You know charge. So if you use, they want capacitance. Capacitance C equals to, yes, Q over V to be used. So Q, you just now you got the Q here on top, the total charge, the voltage is 15. So you can find the capacitance. What unit do you get? Of course, the Q is still microcoulomb, and here is voltage, so you get microfarad. Good. Next. Okay. Anybody? What formula to be used? Half of the energy. What is the potential difference across the capacitor? So you must use the energy equals to what formula? Half QV, half CV squared, half Q squared over C. You want to find final voltage, So, anyone? You know capacitance ready? You want final voltage. So what formula? Half CV squared lah, initial minus half CV squared final. Okay, so this is the formula must come to your mind, right? Capacitance, you know. Okay. So CV final, we are looking for initial or final? We are looking for the final voltage. Okay. Initial voltage is found to be how much? Do we know initial voltage? It's 15 volt. They say it's 15 volt. Okay. So initial voltage is 15 squared. And the capacitor is the trap. What is the trap of a capacitor? Anyone? They give microfarad. When you place here, you must change to farad. You must put it in terms of farad. So this value just times with 10 power negative 6 when you put it into this number. So conversion is always a problem in physics. Be careful. Okay, those who are not realize conversion, I think the substitution itself you lose mark. Okay. Okay. Yeah. Yes. So this is the way you should think about how to get the answer for the potential difference. Any part you don't understand here? You want the final voltage, so VF. The energy formula, you must use this. But how much energy do you put here? Energy is half of its initial energy. What is the total energy? What is the total energy? You know the total energy. Yeah, the total energy. Where's the total energy? Or this is the previous question. They give total energy now. Capacitance, capacitor, charge given, capacitance half its initial energy. Oh, total energy is not given. So total energy, half of it, right? Half CV squared. Oh yeah, the original energy, the initial energy minus the final energy must be the half of the total energy. How do you find the total energy? Anybody? The initial energy is the total energy, right? This minus this must be half of the total energy. So this, when you bring the other side, it's minus minus, is half of the energy. Half CV squared. So it's going to be half of the original energy. The half of the original energy should be the final half CV squared. Half CV squared. Final half CV squared. So how do you find the half of this? Half CV initial squared. So half CV squared. So from here you can work out the final voltage. You can work out the final voltage. Initial how much? Initial is 15. Initial is 15. C, you know, so you can find the final voltage. Okay, any part you don't understand here? Okay, the final voltage of CV squared must be half of the original energy, the total energy. The total energy is, I think you don't need to use this. Straight away you can use this. Half of the total energy is half C final squared, half CV squared, final B. So total energy is half CV initial voltage squared. Okay, initial voltage we know is 15. Initial voltage 15. C we know, just how we calculated. But any conversion to do, again, C capacitance in microfarad must change to farad. Then you can work out the, or C can cancel, easier. Half C can cancel. So you can work out the VF. Okay. So this is the another one question. Okay. So what the question about? First, they show what is the use of capacitor. Next, they show discharging circuit, current versus time given. Area under graph you should know is charge. So they're asking how current and charge related. Current is rate of flow of charge. Okay. So the area below so find the area TDS 4 marks. Then how do you find the capacitance? So QOV. Then only half of the initial energy is already used up. So another half is remain. What is the final voltage? So half of the total energy should be half CV squared. So you get the final voltage. Okay, any questions, guys, from this question? Okay, no questions, eh? Okay, so we have many questions like this on top. Okay, I don't want to do this question anymore. Okay, I want to select some Singapore question. Okay, maybe a little challenging, maybe variety. Eh? Okay, I go to the this is the Singapore one. Okay, Singapore, but challenging. But let me select some question from here. So we go to capacitance. Where's your capacitance? Topic 20, capacitance. I click here. Got that question. This is the capacitance questions. Okay, this all are objective. Your paper, no such thing as objective. Singapore, they have objective. I go straight to the structure. Okay. Okay, I scroll down. Okay. So the question I want you to do, let's we do together, is because not all the questions you can do. Okay, Singapore do a little extra, so I have to select the questions. Okay, the questions I want both of us to discuss is from 34. Yes. Okay, look at 34. You can take a snapshot if you want. Okay, or maybe I send this link to the WhatsApp. Did I give this link to the WhatsApp last time? The Singapore book. Anyone?
Wait.
I send you.
I can't remember.
Can't remember. Okay, I send you back again. Okay. Okay, let's retry this challenging one. 34. Okay, 1 minute for you. Read the question. Get me the answer. 34. Given a number of capacitors, each which a capacitance of 2 microfarad and a maximum safe working potential 10 volt. How would you construct a capacitance of 1 microfarad, capacitance suitable for use up to 20 volt? Let me open up. Sorry. Okay. Sorry. Let me adjust this. Okay. Okay, so anyone? 34A. They have a 2 microfarad, same setting voltage of 10 volt. They want to get 1 microfarad system, but the power supply you're going to connect is 20 volt. So how do you connect the capacitors? In series or parallel?
Series.
In series, right? So you connect them in series. So yeah, 2 microfarad, 2 microfarad. So effective is 1 microfarad. So both going to take 10 volt, 10 volt. Good. So they are safe. So this is the answer for the A. Okay, two in parallel, 2 in series. Okay, B. Total capacitance of 2 microfarad. Suitable voltage again 20 volt. So how are you going to modify the first circuit? I think you can use the first circuit again, but you need to add more capacitors. So how do you connect? How many capacitors required? Another?
4.
4, yes. 2 on top and another 2 at the bottom, right? Yeah, so like this, and you put a 20 volt, yeah. Sorry, yeah, 20 volt again. So up is 1 microfarad, down is 1 microfarad. So mix all of them 2 microfarad. Each get 10 volt, so it's safe. So good. So B is done. Arrangement. Okay, good. Now let's move on to 35. Look at question 35. Okay, part A, you know that. What is defined capacitance? What is capacitance? Capacitance is the amount of charge, is the ratio of uh, charge stored in each plate per unit voltage across the plates. Okay. Okay, B. You can B. Give me the answer. A capacitor of 10 microfarad is fully charged up to 20 volt. Calculate the charge stored in capacitor. So B1, what's the answer? What formula? So C is 10 watt. So C equals to Q over V. Easy, right? C is how much? 10 microfarad. And Q is how much? Q we are looking for. V is what? 20 volt. So Q is 20 times 10 times 10 power negative 6. Don't forget to change micro. So we get the answer in column. You get answer in column. Okay, easy. Okay, 2. Calculate the energy delivered by the 20 volt supply. Okay, how do you do this? Anyone? What formula do you use? What is the energy delivered by the 20 volt power supply?
1 over 2 CV square.
Energy is equal to 1 over 2 CV squared. Okay, this is energy stored in capacitor or energy released by the battery?
Stored in the capacitor.
This is the energy stored in the capacitor. But the top two, they want what? Calculate the energy delivered by the 20 volt supply. Calculate the energy delivered, calculate the energy stored by the, okay, see, calculate energy delivered by the power supply. So half CV squared is energy stored. That's the third part 3 answer. I think this half CV squared is for the part 3, correct? Calculate the energy stored by the capacitor. Part 3 answer is half CV squared. Part 2 answer is what? Anybody?
W equals to QV.
Yes. So E equals to QV. Good. E equals to QV. The power supply, the voltage is 20 volt. The charge release, the charge on top. So put the charge. The voltage is the 20 volt. Yeah, the charge, put the 20 volt, you get the energy release. Okay. Okay. So just follow. Important is the idea. So energy released by the battery is QE. Okay, now can you tell me how do you find the 3 now? Yeah, now you can use half CV squared. So 3 is, this is 2. This is 2. Of course, 3 is the energy stored in the capacitor stored is half CV squared. So C is available, 10 microfarad, P is 20. So you get the energy. Then 4, account for the difference between the answer in 2 and 3. How much do you think the difference is going to be? If this energy stored in the battery 10 joule means the energy stored in the capacitor will be, anyone?
Half of the
10
10 joule.
Yeah, so the final answer should be half of the energy. If this 10 joule, this 5 joule, so the difference should be 5 joule if you get 10 joule. Always half. Okay. Okay, looks easy questions. Okay. Now, let's we go question 38. Okay, look at 38. 1 minute. Okay, I give you 2 minutes. Think about the idea. How do you do 38A? 2 minutes for you. I want the input from you. Okay, so I hope in your mind you have all the ideas. Okay, final answer is fine, but I'm not important. For me, the ideas, what formula, any conversion, that's what I want you to tell. Okay. Okay, 38A, A1. So capacitor marked 100 microfarad, 20 volt. Explain what is meant by a capacitance of 100 microfarad. Anybody? Give a try. Wrong, never mind. Just give a try. It's a learning process, right? Anybody? What is a capacitance of 100 microfarad? What do you meant by 100 capacitance of 100 microfarad? They now give a number. Normally they ask what is capacitance? The amount of charge stored each plate per unit voltage across the plate. But now they give 100 microfarad. What is meant by 100 microfarad? So you put numbers lah. So what is it? 100. The capacitance of the capacitor said to be 100 microfarad when 100 micro coulomb is stored in each plate per unit voltage applied across the plate. That's it. Okay. What is the capacitance of 100 microfarad? The capacitance said to be 100 microfarad when 100 microcoulomb is stored in each plate per unit voltage across the plate. That's 100 microfarad. If you give 1 volt each plate, 100 microcoulomb will be stored in the capacitor. Okay, that's 1. 2, how much energy stored by the capacitor when PD is 20 volt? So what formula? Anybody? Energy stored? You know C, you know V, so of course half CV squared to be used lah. Half C is what? Any conversion? C 100, it should change to -6 farad. V is 20. Okay, so you get the energy in joule. Okay, I think 2 no problem. 3, write down maximum charge which means safely stored by the capacitor. So what formula, anyone? So you know the energy, you know the C, you know the V, or you can work out the maximum stored charge. What is that? C equals to Q over V. So Q is CV, C is 100 microfarad. No need to convert to farad. V is 20, so your final answer is 2000 microcoulomb. Okay. 2000.
So
yeah.
For question 2, they ask for charge, isn't it?
Oh yeah, sorry. Sorry. Question 2, they ask for charge, right? So what is the charge? Charge is, then question 3 is what? Write down the maximum charge which may be safely be stored. How much charge is stored by the capacitor when the 20? Oh. What is the difference between 2 and 3? How much charge is stored by the capacitor when a PD of 20 volt is applied across it? Write down a maximum charge which may be safely be stored by the capacitor. I think printing mistake lah. Because 2 and 3 look same, right? Okay. So maybe one of them will be energy. Okay. I think maybe the top, maybe the bottom is energy. Okay. So that is a printing mistake lah. One of it should be energy. So one use C equals to QOV to find the charge. Another one is E equals to half CV squared. Like you can find the energy. Okay. Or then D, the 4 they're asking for energy stored. Calculate the energy stored by the capacitor when charged as in 2. How much charge is stored by the capacitor? Write down the maximum charge which may safely be stored by the capacitor. Capacitance. So maximum charge can be stored when the voltage is 20. So the maximum charge stored is 2000 microcoulomb. Write down the maximum charge. How much charge stored when the capacitor is 20 volt? Yeah, 20 volt is a safe working voltage. Capacitor marked having a capacitance is also marked 20. Answer 2 and 3 must be same. Answer 2 and 3 must be same then. The fourth one is energy. The fourth one is energy. Okay. So I don't know why they're asking 2 and 3. It's actually same. Okay, B. Answer B. Anybody? Anybody? Why the maximum voltage is stated on the capacitor? So if you exceed that voltage, what will happen? Anyone? Electrical breakdown. We say electrical breakdown will happen. Because a capacitor here, the one our syllabus is vacuum, but normally in the capacitor in between, some sort of insulator will filled in normally. When you go to electrical engineering later, when you talk about capacitor, you're going to talk about a variety of capacitor, which most of them will be filled with insulator. So the insulator carries some electron. So the electron stays in that atom. So of course, when you give a very high positive negative at the plate, electron will move to the try to attract it to the positive, and the nucleus try to attract it to the negative. What happened? The electron will come out. So ionization happen. So electrical breakdown happen. Electrical breakdown. So electrical breakdown will happen. Will spoil or blow the capacitor. That's the answer. Okay. So technical term, you said when the voltage exceeds the maximum value, electrical breakdown happen between the plate. So the capacitor will blow. Okay, or malfunction. Okay, so this is one question. Okay. So this is, there are lots of questions here. I can send the link. Okay, let me go to one objective. Let me select one. Okay, this also not really. Solar dielectric. Okay, good. Number 8. Number 8. Guys, I'm showing the objective. Real exam, no objective. Okay, so no objective. So I'm just showing, normally objective is harder. But let's say treat it like a part A question of a structured question. Number 8. You will try. 1 minute for you. A 10 microfarad capacitor. Okay, anyone got the answer? Shiki, what's your answer?
Is it A?
You go for A, eh? Gavin?
I haven't counted yet.
Okay, still counting, yeah. Marwan?
Still counting.
Still, okay. Take another 1 minute, come on. So Shiki says 4.5. The others, look up. Okay. So the others, how do you do this question? Let me play this. Okay, so they're asking what is the energy. So what is the charge stored in 10 microfarad? How much is the charge stored in 10 microfarad? Okay, so it's the same as charge, the total charge, right? The total charge, because it's one loop word. So you find the total charge now. You find the total charge. So how do you find the total charge? C equals to Q over V. So the Q total is actually C total, V total. So that's the answer, right? C total, V total is your charge stored in 10 microfarad. So C total is what? So C total is 10 and 20. So of course, 1 over 10 plus 1 over 20 reciprocal, your C total. So you get how much? So 1 over 20, 2 over 20, 1 over 20. So it's 20 over 3 lah. Your total capacitance is 20 over 3. And your voltage is what? 3 kilovolts. I put, okay, this is massive conversion. This I put microfarad. Microfarad is times 10 power of 6. Kilo is 10 power negative 6. 3, I think we don't convert lah. We leave it microfarad. Voltage, we leave it as 3 kilovolt. I think the final answer will be in millicoulomb. Yeah. So how much you get?
20.
20 millicoulomb. So you get 20 millicoulomb. So your idea. So Q total is C total, V total. So find the C total. Reciprocal for each. So we get 20 millicoulomb stored in the 10 microfarad. Okay, let me ask you more questions from this number 8. Which capacitor has more voltage? Which capacitor has more voltage? Using more voltage, 10 microfarad or 20 microfarad?
10 microfarad.
10 microfarad, use more voltage. Okay, so the amount of charge stored in 10 microfarad is 20 millicoulomb, 20 also 20 millicoulomb. Total charge stored is how much? Still 20. 20 here, 20 here, total also 20, not 40 in series. Okay, guys, so this is capacitance question, series parallel. You can see lots of questions here, but this is challenging one. The one, the Pastyear I give you is quite easy. If you have time, you can go through here. At the back of this book also, they give answers at the back. There is answers at the back, but all are numerical one only. Explanation, no explanation. We have to figure out. Okay, I send you this link again to the WhatsApp. You can give a try. Okay, so we're done with this topic. So tomorrow we start with the next topic, magnet. Any questions? No questions, Okay, so I see you tomorrow. Okay, bye.